Okay, so the purpose of this video is to demonstrate the kinematic equations that was derived in our week 2. These kinematic equations are the equations for constant accelerations that are used for one-dimensional motion. So let's say we have our kinematic equations, which is basically equal to your S is equal to VIT plus 1 half AT squared. So why is it that it is just S? Take note that you are considering this one that your SI is equal to 0. That's why you have our S or SF. Next is your VF less VI is equal to 80. Next is your VF squared minus VI squared is equal to 2AS. F, considering that your SI is equal to 0. So the derivation of these formulas was in your week 2 or in your week 3 modules. So, paano ba natin pwede gamitin itong mga formulang to? Take note that these formulas are only used in constant acceleration. Pag paiba-iba yung acceleration mo, pwede mo siyang gamitin. As long as yung acceleration mo is paiba-iba siya, pero linear pa rin siya. Example of this one is pag ito yung graph ng acceleration with your time. So, let's say from 0 to 1 seconds, ito yung acceleration mo. Let's say 1 meter. And then, from 1 to 2 seconds, biglang bumaba yung acceleration natin pag ganito. Okay? From 3 to above, sabihin natin tumaas siya. Yan. 0.5 hanggang sa 2 meters per second squared. So take note that you can still use this constant acceleration motion equation by carefully limiting your time interval. Pero pag yung graph mo is hindi ganito, hindi constant acceleration ng graph mo, therefore you cannot use this one. Okay? Because that would be another story. So another thing to remember is that if you have a constant velocity, ano mangyayari sa acceleration nyo? Velocity. Anyone? Pag yung meron na yung constant constant velocity, so yung acceleration nyo must always be equal to 0. Bakit? We all know that A is equal to dv over dt. And based on the rule of your differential calculus that any derivative of a constant will always be equal to 0. Why is it that it is equal to 0? Because particularly your derivative is just equal to delta u over delta t as delta t approaches 0. So, pag constant to, so t1, u1 less u2, saying that u1 is equal to u2, di 0 yan. Tama ba? Okay, ganun lang yan. Next is that we would apply these kinematic equations into a real problem. Not a real life problem, but a problem. Okay? Kasi pag real life, wala naman talagang tumatakbo sa one-dimensional motion. Okay? So, let us use these equations in solving this problem. Okay? Always take note of your analysis of the problem. Huwag kayo mag-analyze ng problem, lalo na pag hindi naman time limited, huwag kayo mag-analyze bigla-bigla. The first thing to do is to read the problem carefully. The driver of a car slams on the brakes when he sees a tree blocking the road. The car slows uniformly with an acceleration of negative 5.6 meter per second squared for 4.2 seconds, making straight skid marks 62.4 meter long all the way to the tree. With what speed does the car then strike the tree? Okay, next, first assumption, VF is not equal to 0. Bakit? Always take note na pag sinabing VF is equal to 0, dapat merong mga word na stop. Okay? If nag-stop siya, therefore, VF is equal to 0. In this case, wala siyang sinabing mag-i-stop yung car. Tuloy-tuloy lang yung car until mabunggo niya yung tree, pero hindi siya mag-stop agad. Ang sinabi niya is that, mabubunggo naman yung tree. Ano yung final speed niya bago niya ito mabunggo? Okay? Next is yung acceleration natin. Take note that at this problem, the negative 5.6 meters per second square dictates a deceleration. Negative always state a deceleration. So A is equal to negative 5.6 meters per second squared. And then we have our D. So take note that our D, or the distance, is the distance traveled, 62.4 meter. It is, or your S displacement. So in one dimensional motion, your S is synonymous with your D. Okay? At your S, so we have 62.4 meters long. Then mag-skid siya. Stage skid with 62 meter long, and then mag-stop siya at 4.2 seconds. So take note that is the displacement, or the distance traveled at 62.4 meter. Take note that distance and displacement is synonymous at one-dimensional motion, considering that your acceleration is the positive displacement of the motion. Okay? So meron kang 62.4 meter, and then at time equals 4.3 seconds. 4.2 seconds. Ito yung time wherein nag-travel yung car nyo. Take note, in making a free body diagram for kinematic problems, always consider your free body diagram as particle. Bakit particle? Kasi nire-neglect natin yung weight niya, nire-neglect natin yung other aspects niya, yung dimensional aspects niya. We are only allowing ourselves to consider the graphical characteristics of the problem. Sabihin natin ito yung tree. Wala siya. Iba yung tree. So, within this moment, within this diagram, you have our 62.4 meter at VI, which is unknown, and then we have our VF nung bumangga siya dito. Okay? Considering that VF is not equal to 0 because it does not have the word stop. Okay? Continue siya. And then, take note that the interval of time wherein nabangga yung tree is equal to 4.2 seconds. Okay? So, ang tinatanong niya, all the way to the tree, with what speed does the car strike the tree? What speed does the car strike the tree? So, how will we solve this one? May dalawa tayong solution dyan. Particularly, makukunin mo yung VI. First step is solve for VI. After solving for VI, substitute the value of your VI to your second equation. Since you already have our A and T, then we can solve for our VF. Or, we can solve using your VF less VI and VF squared less VI squared equals to ASF. So, yung sinabi kong kanina, method kanina, yun yung pinakamabilis. Okay? But, let us go with these two equations. Your VF less VI is equal to AT, and VF squared less VI squared is equal to 2ASF. Okay, let's go. So, we all know that we have VF solution. So, sa baba, no? Solution. We have our VF, which is unknown. We have our VI, which is unknown. We have our SF, which is equal to 62.4 meters, and T, which is equal to 4.2 seconds. And take note, we have our acceleration, which is equal to negative 5.6 meter per second squared. Pag ako nagsosolve ng problem na ganito, I always make sure that my acceleration dictates the motion of the problem. Diyan ko binibase kung positive or negative siya. Actually, pwede mong i-base yan. Going to the right is positive, going to the left is negative. Going up is positive, going down is negative. But for me, even when I was a student, I always consider as the direction of my acceleration as the positive direction of the motion, either deceleration or acceleration. Kasi pag deceleration kasi, magde-negative lang yung acceleration mo, which means that your body is slowing down. Okay? Pag positive acceleration naman, your particle is speeding. Bumibilis siya. Pag negative acceleration, bumabagal siya. Yun lang yung analysis ko sa isang kinematic equation problems. So, always take note na particle lang yung kino-consider natin yan. Ha? Okay? So, we have our acceleration which is equal to negative 5. Acceleration is equal to negative 5.6. So, gamitin natin to. VF less VI is equal to AT. Okay? So, madali lang i-memorize itong mga to, di ba? Pag VF less VI is equal to 80, take note na yung end unit mo is meters per second. Tama? Meters per second yan. Meters per second to. Meter per second squared multiplied by seconds is just equal to meter per second. So, hindi nyo kailangan pagbaliktad yan. Okay? So we have VF less VI is equal to A, which is, so positive yung acceleration ko. Mag-substitute tayo ng negative acceleration kasi deceleration siya, negative 5.6 multiplied by our time, wherein na-meet niya yung 62.4 meters, so 4.2 seconds. So calculating this one gamit yung calculator niya. So always take note na pag nakikinig kayo sa mga ganitong videos, meron kayong kasamang calculator. So we have negative 23.52. So meters per second squared multiplied by meters. So 23.52 meters per second. Second to. Second. 4.2 seconds. So negative 23.52 meter per seconds. Next is, okay, we have our first equation. So let's say this is my first equation. Equation 1. Ito yung solution na farm muna bago kill. Okay? Yung isa kasi kill muna. Kill agad. Yan. So ito, farm muna bago kill. Next is we have our VF squared less VI squared is equal to 2AS. F or S lang. So, mapapansin mo, madali lang ding i-memorize to. Paano mo malalaman kung misleading yung formula na ginagamit mo? So, take note that our VF is meter squared per second squared kasi squared siya. Ganun din yung VI natin. Particularly, our ASF is meter per second squared multiplied by meter. So, we have meter squared over S squared. So, parehas lang yan. Tama? Kasi nga, you cannot add or subtract any variables with different units. Ganun lang yun. Okay, yun yung concept natin sa first week. So, interconnected yan. So, we have VF squared less VI squared is equal to 2A, so which is negative 5.6 multiplied by 62.4. So, 62.4 meters. So, we have 2 times negative 5.6 times 62.4. So, always take note na dapat may calculator kayo sa tabi nyo. So, we have negative 698.88, which is VF squared less VI squared. So, square root natin yan. Tama? Mali. No. Because, that would be a mathematical error kasi hindi mo pwedeng square root yan. Kasi nga, hindi naman nasa labas yung square ng variable mo. Tama? So, ang gagawin natin, i-factor natin to. So, VF less VI multiplied by VF plus VI. This is a special factor. Okay? A plus B multiplied by A minus B. Right? So, which is equal to negative 698.88. So, reviewing special product siya, makikita yung formula na yan. Next is that we all know that we already have our VF less VI. Tama ba? So, pwede nating substitute yung value ng VF less VI natin dyan, which is basically equal to negative 23.52 multiplied by VF plus VI, which is equal to negative 698.88. So, VF plus VI, mathematically, so this is equal to negative 698.88 divided by negative 23.52. Tama? So, divided by 23.52. We will have a value equal to negative VF plus VI is equal to positive 29.71428.571 or store at A. Okay? Stored at A. Yung stored at A sa calculator yan. So, if you will be in an actual, let's say, actual school year, so it is better to write your storage kung saan yung i-store sa papel nyo para pag hindi kayo basta-basta nag-clear ng memory ng calculator nyo or nagre-recompute or nag-i-input agad. Okay? So, this is our second equation. Okay? So, pwede yung compute yan gamit ang mode 5.1. Mode 5.1. Wherein we have your input VF less VI is 1 equals negative 1 equals negative 23.52. So, equals 1 plus 1 plus 29 alpha A. Okay? So, may makukuha ko yung sagot. Or, ang pinakamabilis gawin is that i-diretso na siyang i-subtract. Okay. So, pag sinubtract natin siya, so mapapansin mo that you would get the value of your VI. But if you would add this one, so add them, so add equation 1 and 2, add equation 1 and 2, so we will have VF plus VF is equal to 2VF. 2VF. And then, yung VI, negative VI plus VI is equal to 0, which is also equal to negative 23.52 plus 29.71. So, we have a value equal to negative 23.52 plus 29.71428 or plus A. So, we'll have a value of 6.19428. So, adding equations 1 and 2. So, dito lang mabilis guys, no? Kasi explanation to. So, divided by, so we have VF is equal to 6.19428 divided by 2. So, we have divided by 2. We have 3.097 or simply 3.0971. So, meters per second yan. Pag nag-input kayo sa LMS, ang gagawin nyo is that, pag sinabi kong round to the nearest hundreds, re-round ko yung 9, so therefore, we will have a value equal to 3.10 meters per second. That is the answer, or that would be the answer that you should input into your LMS. Okay? So, ganun lang kadali yan, no? Okay. So, kung gusto nyo tignan yung calculator natin, calculator techniques natin, okay? Ito. So, dun tayo. Okay. Ang gagawin is mode. Pag gamit yung calculator nyo sa Casio, 991ES, mode 5 yan. Mode 5. So, dito, hahanapin ko yung ito. AX squared plus PX, AN plus PN. Yan. Mapapansin nyo, may makikita agad kayong 2 equations, 2 unknown sa calculator nyo mismo. So, what are our inputs? So, we have VF as 1. So, take note ng VF nyo. So, ilalagay ko siya sa column A. VF will be at column A. Pag sabihin natin ito yung calculator nyo, meron tayong A, B, C. Tama? So, yung VF natin is 1. And then yung VI natin is negative 1. Take note that I will consider my column A as my VF as my and I my column B as my VI. So 1, negative 1, and then 1, and then 1 again. VF, VI, 1. And then yung value ng C natin, which is basically equal to negative 23.52. And then we have positive 29.714837 1. Okay? But particularly sa mga naka-store ng value ng 29.71428 yung as A, pwede yung ilagay yan sa calculator natin. Okay? So 1, negative 1, negative 23.52, tapos 1, positive 1, tapos 29.7148371. Okay? Using our calculator. So, mapapansin nyo, pati na rin sa 991ES users, this notation. Kaya, may equal sign siya dito, tama? Which means that, you must transpose your constant value to the right. Yan, kaya nakatranspose yung ginawa natin. So, we have 1. So, input mo lang, 1 equals negative 23.52. So, equals positive 1, then we have 29.7148371 equals. So, we have no solution. So, ibig sabihin nun, nagkamali ng pag-input. Yung B natin dapat negative 1. Yan. Yun. So, 3.9741585 as your VF and your VI is 26.617411855. Okay? So, anong implication yan? Take note that we set your A as your VF and then yung BI nyo as your VI. Okay? And then, yung constant. So, whatever value of x will be, that will be the value of your Vf, and then your y is Vx. Is this interchangeable, sir? Yes. But take note that if you already choose your A as your Vf, therefore, all the way na lahat ng equation na input mo sa calculator mo dapat Vf na at A. Pag B naman, pag choose mo sa as your Bf, dapat your two equations must coincide with the Vf notation. Okay? Kasi pag nagbaliktad yung input mo, let's say your A is 1 as your Vf to, di ba? In-assume mo siya ng Vf and then nag-input ka siya ng negative 1 dyan and then positive 1 to, you will get a different answer. So, upon pag tinignan mo mabuti yung mga sagot mo, which is basically 3.97, which is yung Vf mo, mas mababa siya sa VI mo, it means that your car nag-decelerate siya, di ba? So, pag napagbaliktad mo ngayon, yung inputs mo sa calculator mo, magiging yung VI mo, yung VF mo is 26.61 and then yung VI mo is 3.3, mali na, tama? Kasi nag-accelerate yon. Okay? So, before answering the problems, you must also analyze whether your solution or your answer is correct by simply knowing the concept, basic concepts. Na pag nag-decelerate siya, dapat mas mababa yung final velocity mo kaysa sa initial velocity mo. Okay? So, let's go back to the board, our report. So, based on our equations, our VF is equal to 3.097 or approximately equal to 3.10 meters per second, and then yung VI natin is equal to 26.617 meters per second. Okay? Nag-decelerate siya. Bakit? Particularly, your VI, nung hindi pa niya nakita yung track, yung VI nyo is 26.6162 meters per second. And then, nung bumangga siya dito, nag-decelerate siya kasi nga nag-hit siya ng brake. Okay? To 3 point. Pag gagawa ka ng graph ng velocity mo, mapapansin mo na mas mababa siya kaysa sa initial mo. Okay? So, ito yung graph niya. 62.4 meter, bumangga siya sa track, meron siyang 3.1 meters per second. So, pag kinonsider mong graph yun ng velocity of time. Okay? So, tanggalin natin. Pangit eh. Yan. So, that is our solution for your first equation. Actually guys, pag master mo na yan, mabilis lang siya. In minutes, let's say 2 minutes, solve mo na yan, or in seconds pa nga.